Hello and welcome back to the lecture of time series econometrics. Over the past few lectures, we have been discussing the idea of forecasting in time series analysis. And in this lecture, we are actually going to talk about the Holt-Winters exponential smoothing forecasting technique. Now, if you remember, we have been talking about different forecasting techniques like exponential smoothing, Holt exponential smoothing, and now we are talking about Holt-Winter exponential smoothing. So the difference between these topics, these techniques are, when we use a simple exponential smoothing, we assume the data is completely stationary. We don't have the data doesn't have any trend, any seasonality. But when we talk about say Holt's exponential smoothing, then we know that we are going to use that technique when we have a trend in the data set. Whereas in Holt-Winter exponential smoothing, we use this technique when we have both seasonality and trend is present in your data set. So it's a advanced sort of exponential smoothing technique as opposed to the other ones. And Holt and Winter, Winter was a student of Holt, and they together actually created this technique. Okay. Now, before I proceed further, let me actually show you some data where we might have some seasonality which we want to adjust. Okay, so let's see. We plotted this data set in R, where we this data set is this purchasing parity index for US economy. Let me clean this one. Let me clean this one too. So the purchasing parity index in US economy, we have used this TS function, which is time series function, and we actually have this data from 1960 period 1 and to 2002 period 1. So it's a quarterly data. Frequency is equal to 4. And if we plot this, we will see that object PPI not found. Oh, so basically I have to run it one more time. Just a second. Let me just get that data set. Okay, so all right. So okay, now it should work, and I plot it. So basically, what I get here is in this um, plotting this PPI values over the period of this time series, I see that there definitely is a trend, no doubt about it, and it looks like there could be some seasonality as well, right? Okay, okay, so we need to kind of adjust for that, and that's what the whole winter exponential smoothing is all about. Before I actually get into the technique of whole winter exponential smoothing, let me actually show you how there could be different ways we may have seasonality in the data, and let me just show some of those techniques, some of those kind of some of different ways how the seasonality could be present in the data set. So for example, we can have say no trend but seasonality. So no trend but seasonality. Say additive. So seasonality. Okay. So we draw it like this. No trend, seasonality. Okay. Then we can have no trend but say multiplicative seasonality. No trend, multiplicative seasonality. So this one, say let's say seasonality additive. Okay. And here it is seasonality multiplicative. So it will look like something like this. All right. It will look something like this. Okay. Then the another case could be we have say a trend, additive trend, and we have some say additive seasonality. So if you have additive trend like this and your additive seasonality like this, so the plot would look like this. So like additive trend and seasonality additive. Okay. Then we can have additive trend and say seasonality multiplicative. Okay. So this will look something like this. All right. This will look something like this. Now then other case could be you might have a sort of a equation where it's basically mm, multiplicative trend you talk about. So which means that a good example of multiplicative trend could be y equal to x squared type graph, and you have this, and there you plot seasonality. Okay, so oops, it's not really happening. So yeah, something like this you can have as a multiplicative trend and seasonality additive. Okay, then you can have another case where you can have say multiplicative trend and multiplicative trend and say multiplicative seasonality. Okay, so that's like this one. So we write MT seasonality multiplicative. Okay, so these are the few cases where you can see seasonality in different form. Okay, So now we'll delve into actually explaining how this uh, Holt-Winter method actually works. And to do that, let me again go back to my whiteboard and I will actually derive the formula, and we'll see that Holt-Winter method is nothing but an extension of the, from basic exponential smoothing to Holt exponential smoothing to some others. When we add seasonality component to Holt exponential smoothing, we get Holt-Winter exponential smoothing. All right, so another concept that we'll be requiring is called seasonality index. Okay, seasonality index. So we get seasonality index by actually what we do here is we say, suppose we have this data, this PPI data, and we have data from say 1961 to say 2002, right? 2002. And what we do is we have 4-quarter data, right? We have 4-quarter, sorry. We have 4-quarter data, Q1 to Q4. And basically how we measure seasonality index is, it is basically seasonal variation measured in terms of index. So it is an average that can be used to sort of compare an actual observation vis-a-vis the observation if there is no seasonality. So we can say an index value that is attached to each period of the time series within a year. I mean, it's like uh, a value that actually counts for the seasonality. Okay, so if you take out that index, your data becomes basically free. And how we do that? So for example, if we have a quarterly data, so you have say, for you take the average for all the quarters. Say here you have AVG Q1, this AVG Q4, and here you take basically the average of the whole data set. Okay, average of all the quarters. So okay, so you take all the quarters and you take the average of that. And if you want to get the seasonality index for Q1, seasonality index for Q1, so that is going to be your average Q1 by average of all quarters or all observations. They're basically the same, average of all observations. Okay, so basically this, it is as if when I get this ratio, this seasonality index, it basically means that seasonality of that particular time period. Okay, so let's just use this, we learned it and we'll use this idea to sort of explain the Holt-Winter method. So it is also called triple exponential smoothing. The simple exponential smoothing was just exponential smoothing, whereas Holt's exponential smoothing was double exponential smoothing. And this one is called triple exponential smoothing because you are, sort of taking care of 3 factors. One is the level, second is the trend, and third is the seasonality. Okay. So let us remember the level updation equation. Okay, so we will be again, like we'll be using the same concept of exponential smoothing coefficients and level updation equation. So again, we have 2 components: exponential smoothing coefficients and level updation equation. Okay, sorry, updation equation. Basically, we have level and trend and seasonality. We'll have 3 types of updation equation. Updation equation. Updation equation. Okay. So let us write down first, say, level updation equation. Level updation equation. Level updation equation. Say we have used previously, say LT is equal to alpha YT plus 1 minus alpha LT minus 1. So, right. So that was our level updation equation that we have used for, say, Holt's method. But here we do a small adjustment. We do a small adjustment. That is the seasonality adjustment that we do. We actually divide it by seasonality index. So that means the moment you divide it by seasonality index, you are basically left with you are basically deseasonalize the observation. So that's basically the purpose, and you add a component of level by deseasonalizing this observation. Okay, so you basically what you get at the end of the day is a level, a new level LT. The second equation is the trained updation equation. Trained updation equation. And if you remember, previously we had our trained updation equation. TD is equal to beta LT minus LT minus 1 plus 1 minus beta into TT minus 1. So basically, here you see we are only talking about the trend. So we are talking about the levels, which is already free of the seasonality component. So I don't have to do any adjustment for this. We are already using trend, which is free of seasonality or any other thing. So basically, we don't have to do any adjustment for this. So that is why this equation, the second equation, is just as it is what we have seen for the Holt exponential smoothing. Okay. Now there is a third equation here, and that is called seasonality updation equation. See, seasonality updation equation, and how I'll write it is ST is equal to gamma. So this is a different exponential smoothing coefficient, YT plus 1 minus gamma ST minus M. Let me explain this equation. Oh, so I have to update it with the level. Okay. So what I'm doing here is, in this case, I'm assuming that if my YT has some component of seasonality, and if I adjust it with the level, so what I'll be left with is the seasonality component. So this part is a seasonality component, and this part is also a seasonality component. So that is how we basically use these three different equation to sort of solve our exponential smoothing problem using Holt-Winters equations. So in the next lecture, we are going to see how to actually solve Holt-Winters exponential smoothing and basically get those forecasting values using R.